This is Geometry 7.1. We're going to use proportions to solve geometric problems. So if A and B are two numbers, two quantities, but B is not 0, then the ratio of A to B can be written as a fraction. That's a very common way to write it. Be written with a colon. Is another way to write a ratio. This is the type that might show up on a standardized test. That gets us all confused. But if we convert it over to a fraction, it makes more sense to us. And then, of course, like they did earlier, you can use words. A to B. So those are kind of three different ways that a ratio can be written. A to B implies that the A is on top of the fraction and the B is on the bottom of the fraction. Sometimes they call it length to width, and that tells you how to set up your ratio with length on top and width on bottom. Here we're going to work on simplifying. To simplify our ratios, we need to be sure we're in the same units. So here's centimeters. So I would suggest to switch that into a fraction, because that's the format we're most comfortable with. You've got to figure out what goes into these. I know 2 goes into both of these. 2 goes into this 38 times. Ooh, that's an even number. So I could do 2 again. So I bet 4 goes into both of these. And we reduced it by 4. 4 goes into 7 one time with 1 left over. 4 goes into 16 4 times. I'm sorry, that's not quite right. It's not 1 left over, it's 3 left over. When 4 goes into 7 one time, there are 3 left over. And then that's going to give us 19. Because 4 goes into 36 9 times. And then 4 goes into 8 twice. So there is our new ratio. 76 centimeters to 8 centimeters. So if you're building a dollhouse and you're scaling it down, what used to be 76 centimeters is now going to be 8 centimeters. Is at the same ratio as 19 centimeters is now 2 centimeters. Here we have 4 feet to 24 inches. Well, these units are different. You have to be observant and recognize that they're different. Now, it doesn't matter if you switch them from feet to inches or inches to feet. I would suggest to make your numbers smaller, don't make your numbers bigger. So if there are 12 inches in a foot, I would have to times all 4 feet by 12 to get 48 inches. That's a bigger number. I'm going to choose not to do that one. I know that there are 12 inches in a foot, so I'm going to divide the 24 by 12. That gives me 2. There are 2 feet. In those 12 inches. Then I can write it as 4 over 2, and I can simplify that to get 2 over 1. So 2 feet to 1 foot. Simplifying that down. Yards and feet. there are 3 feet in a yard. So if you wanted to figure out how many feet 33 yards are, you have to times 33 by 3 and get 99. You could do that. Totally works. But again, that's making the number bigger. So I'm going to take my 9 feet, which is even less yards. So we're going to divide that by 3, because there are 3 feet in a yard. So how many times are there 3 inside of this? And that's going to give us 3 yards. And then you can write your fraction and simplify it. You've got to get your units the same first. Now here's probably the most complicated question that we have. These two, for example, number 2. This extended ratio. You've got to pay attention to what it's talking about. Over here is what it's talking about. The angles of a triangle. Angles of a triangle. You know that the angles of a triangle, angle B plus angle C plus the measure of angle D. What do you know about the angles of a triangle? What do we always know about every triangle? The sum is going to be 180 degrees. So we know those 3 angles are adding up to 180. Now look here, they tell us that they are at an extended ratio of 2, 3, and 4. That means the numbers for those angles can be reduced to 2, 3, and 4. It's an extended ratio. So it's possible the numbers are 20, 30, and 40. But does that add to 180? No. Maybe you times it by 5. 10, 15, and 20. 2 times 5, 3 times 5, 4 times 5. That doesn't seem to add to 180 either. Maybe it's times 100. 200, 300, 400. No, that's way too big. So it's times something to each one of these values. So what we're going to do is say 2x plus 3x plus 4x equals our 180. That's your extended ratio. 5 plus 4 is 9, so this is 9 x's. We're dividing by 9. So x is 20. So one of our angles is going to be 20 times 2. The other angle is going to be 20 times 3. And the third angle is going to be 20 times 4. That adds up to 100 and then 80, 180. Let's try it with the perimeter of a rectangle. The perimeter of a rectangle equals 21. So go ahead, pause the video and give this ratio a try. The length to its width is 5 to 2. So what is the length and the width going to be if we know the total perimeter is 21? All right, what we recognize, we're dealing with perimeter of a rectangle. So think about what your rectangle is. And length to width is 5 to 2, so you know your length is the longer part. So here's your length, Here's your width. Here's another length. And here's another width. So a common mistake is just to call it 5x and 2x. But don't forget, if we're talking about perimeter, we have to go all the way around the rectangle. So we're going to have two lengths and we're going to have two widths that make up your 21. 5x plus 2x and 5x plus 2x are going to add up to be your 21. That's a total of 10x plus 4x. That is 14x equals 21. When we divide by 14, we have to simplify this, it looks like, by 7. And that gives us 3 halves. 1.5 essentially. So the length is going to be 5 times 1.5. That's 15 halves, which is 7.5. And our width is 2 times 3 halves, which is 6 halves, which is a length of 3. 7.5 and 7.5 is 15. 3 and 3 gives us 6. 15 and 6 is 21. So those would be our side lengths. So you really have to pay attention to what it's talking about. Not just jump to conclusions. Okay. An equation that states that two ratios are just fractions, two fractions are equal, is a proportion. So here's an example of two fractions or two ratios that are equal to each other. So this is a proportion. To solve a proportion, we can cross multiply, and I would suggest for you to physically circle the diagonals. That tells you that the A and the D are multiplying each other. So A times D and B times C, those are also going to be equal quantities. So to solve this, we're going to cross multiply because this is a proportion. We have two fractions that equal each other. So we have 3 times 16 and we have 4 times x. Three times 16 is 48. And then we divide. 4 goes into 4 once, 4 goes into 8 twice. So this becomes 12. So 3 over 4 is the same thing as 12 over 16. 12 over 16 can be reduced into 3 over 4. Here it's a little bit more complicated because we have a binomial on top. We have x minus 3. So when we cross multiply, we're going to have 9 times that quantity. So you have to use parentheses. So 9 times x minus 3. And 2x times 3. So we're going to distribute our 9 into the parentheses to get 9x minus 27 and 6x. Now you want to get your like terms together. So your x's are your like terms. So I'm going to move my 9 underneath my 6. I could have moved my 6 underneath the 9. That would have been fine. But then I would have had the 27 and the x's all on the same side together. So I'm just trying to get my x's isolated. So this is negative 27 equals negative 3x. So we're going to divide by negative 3. And that gives us 9. So 3 times 3 makes 9 in the denominator. And if you put 9 in for x, that's 9 minus 3, which is 6. And 2 times 9, which is 18. 6 times 3 makes 18. So it's got the same proportion. All right, other properties about proportions. If two ratios are equal, then their reciprocals are also equal. You should know what reciprocals are. Reciprocals are when we flip the fraction over. So, before we move on, let's come on down here to example 4, and we're writing this in 4 different ways. So we're going to work with the reciprocals. So the reciprocals of this proportion, you flip the fractions over. So df over AC is going to equal EF over BC. That is a different proportion because the names are in different locations. But what makes it still equal is because both fractions were flipped over. So if you had to solve this proportion, you would get the same answer as you would here. Your cross multiplying brings the same letters are multiplying each other. AC and EF. AC and EF are still multiplying each other. Okay, let's look at the other property. If you interchange the geometric mean of a proportion, then you form another true proportion. Well, looking up here, it talks to us a bit about a geometric mean. A geometric mean are your two values that are cross from each other. Not straight across, but when we cross multiply, what those two values would be. That would be your geometric mean. So a geometric mean would be switching these two values. As long as they're still going to multiply each other, BC and DF, then it's still going to be equivalent. We'll keep the AC on top, but we're going to switch the order of our BC and the DF. So put BC on bottom and DF on top. Keep the EF on bottom still. This proportion is still the same. We just switched the two values that would be multiplying each other when you're solving. Those are called the geometric means. We switched those. But if we cross multiply, they'd still be in the same pattern of multiplying. You could even switch the other direction. The AC and the EF. So you've put the EF on top and the AC on bottom of the other side because you switched the EF and the AC. Keep the DF and the BC right where they're at. That proportion would be the same. Just another way to write the same proportion. So if you have to write a proportion, there are actually several ways to write it correctly, but there's also ways to write it incorrectly. So different people can have different answers for their proportion. Now this is the weird one. In a proportion, if you add the value of each ratio's or each fraction's denominator to its numerator, then you form another true proportion. So, if we take the denominator and add it to the numerator, AC plus DF over DF, you could not cross those DFs out, and BC plus EF over EF. That would be a different proportion. So you now see that we have 4 different proportions that we could write from a single original proportion. So let's solve for x. You can take any of these. It really wouldn't matter which one you took. But let's take the AC, which is 12, the DF, which is 18, the BC, which is 9, and the EF, which is x. We cross multiply, gives us 12x and 162. Divide by the 12, that gives us 13.5. So our x value is 13.5. Last one. JL. JL is part of this length. LH is the little part down here. JK is the 15, and the KG is the 5. So you can cross multiply. Now notice this one. I am just reducing. I cross multiplied in only one direction because there was no need to bring the 5 up and divide it again. So that just saved us a step. So JL is 6, where JH is the combination of JL and 2. So JH is going to be 6 plus 2, which is 8.